Now we take another example, that is, let x1, x2 up to xn be the IID random variables from normal distribution with mean mu and variance sigma square. And now consider the estimation of sigma square. Now that is little bit different case. We are now considering the estimation of sigma square. So basically our main focus on sigma square, and we assume that mu is known. So mu is known, and we are going to find and discuss regarding to the sigma square and show that the normal distribution satisfies the assumption of the Rao-Carmer inequality. So how we proceed for this one? We know that the PDF of the normal distribution, that is f of x into 1 over 2 pi sigma square under root exponential minus x minus mu whole square over 2 sigma square. And we know that normal distribution lies between minus infinity to plus infinity. Now first of all we take the log of this function. So log of f of x, that is actually minus 1 over 2 log of 2 pi. We are merging these quantity 2 and pi in the same because there is no sigma, so we can merge because that is a constant when we are going to differentiate with respect to sigma square. So that is the next one, that is 1 over 2 log sigma square minus 1 by 2 sigma square into x minus mu whole square. So we have to differentiate, partial differentiate with respect to sigma square. So that is curly log f of x और curly sigma square. So that will be, इसके लिए जब हम करेंगे तो ये हमारे पास आ जाएगा minus 1 over 2 over sigma square. ये नीचे आ जाएगा हमारे पास जब log लेंगे, और जब इसके हवाले से करेंगे तो ये ऊपर जाएगा और ये प्लस आ जाएगा हमारे पास, और ये हमारे पास आ जाएगा x minus mu whole square over 2 sigma raised to power 4. Now we use the criteria curly log f of x over curly sigma square whole square, इसका ले लें आप, and that is equal to, जब square whole square लेंगे तो इस साइड पे भी whole square लेंगे, and that will be 1 over 4 sigma raised to power 4 plus 1 over 4 sigma raised to power 8 into x minus mu raised to power 4 minus 1 over 2 sigma raised to power 6 into x minus mu square. Now we take the expected value on both sides, that is expected value of this term curly log f of x over curly sigma square whole square, that is the constant, so it will remain as it is, that is 4 sigma raised to power 4 plus, इसको हम ऐसे लिख सकते हैं, that is 1 over 4 sigma raised to power 4 into expected value of x minus mu over sigma raised to power 4 minus, इसको हम ऐसे लिख सकते हैं 1 over 2 sigma raised to power 4 into expected value of x minus mu over sigma whole square. Now we have to find the expected values of these two. So how we proceed for this one? The expected value of, I will do one and the rest of the other one on the same line, you can find it, that is expected value of mu minus sigma x minus mu over sigma whole square, and that is equal to minus infinity to plus infinity, and that is x minus mu over sigma whole square into 1 over 2 pi sigma square under root into exponential minus x minus mu square over 2 sigma square into dx. So if we substitute let z is equal to x minus mu over sigma, so which implies that sigma dz is equal to dx. So we can write it as the expected value of x minus mu over sigma whole square. This is a symmetric integral, so we can write it as 0 to infinity. और हम 2 लगा देंगे तो we use the property of the integral. When the integral is symmetric, we can write this one. So that is 2 over 2 pi under root, that is z square into exponential minus 1 over 2 z square dz. And again, if we put z square over 2, that is equal to t, and we solve it, that is again very simple integration. We solve it, we will find the result, that is expected value of x minus mu over sigma whole square, that will be equal to 1. And on the same line, I'll just writing the result directly. You can do on the same line, that is the expected value of x minus mu over sigma raised to power 4. On the same line, you will proceed and you will find the result, that is equal to 3. So we put these results in the previous equation. So that is expected value of curly log f of x over curly sigma square whole square, that is equal to 1 over 4 sigma raised to power 4 plus 3 over 4 sigma raised to power 4 minus 1 over 2 sigma raised to power 4. And when we simplify this one, we will find 1 over 2 sigma raised to power 4. So, any unbiased estimator, say sigma square, must satisfy the condition, that is the variance with respect to sigma square of, let's say our estimator is Tn, that must be greater than or equal to 1 over n expected value of curly log f of x over curly sigma square in this case. So this is basically equal to 2 sigma raised to power 4 over n. So an unbiased estimator of sigma square, when mu is known, then sigma square hat is equal to 1 over n sum xi minus mu square. So it attains the Carmer-Rao lower bound. But if mu is not known, then what will happen? If mu is not known, then the variance of s square, we know that it is equal to 2 sigma raised to power 4 over n minus 1. So in this case, it will not attain the Carmer-Rao lower bound. So when mu is known, it attains the Rao-Carmer lower bound. But if mu is not known, in this case, it will not attain the Rao-Carmer lower bound.